have to start today's deep dive with a confession. It's something that happens to me almost every single week at the grocery store, and it drives me absolutely insane.
Oh, I'm intrigued.
It's the specific moment of paralysis. I'm standing there in the produce aisle, trying to be a good eco-conscious citizen.
Mm-hmm.
I've got my reusable canvas tote bags. I've managed to avoid buying the water in the plastic bottle. Feeling pretty virtuous. And then I reach for a cucumber.
Let me guess. It's wrapped in plastic.
It is shrink wrapped individually, like it's some kind of precious, fragile artifact that can't be exposed to the oxygen in the room.
I know exactly the one you mean.
And I just stand there staring at it thinking, why? Nature gave the cucumber a skin. It has a peel. It literally evolved a wrapper.
It has its own packaging.
Exactly. So why are we wrapping a biodegradable vegetable in a material that is going to sit in a landfill for 500 years? It feels like the ultimate symbol of environmental negligence.
It definitely feels that way. It's a visceral thing. You see that plastic and your gut just screams, waste.
Right.
Wrong.
It feels like a crime against the planet right there in the palm of your hand. But, and I know you're going to hate this, what if I told you that tiny layer of plastic might actually be an environmental hero?
Okay, you are trying to provoke me right out of the gate. A hero.
Oh.
That feels like a massive, massive stretch.
I know.
I mean, I'm looking at a piece of trash and you're telling me I'm looking at a hero.
It does sound like a stretch until you start looking at the data. And that is exactly what we are doing today. We are looking at the food system, but we're looking at it through a really wide lens.
The system view.
The system view, exactly. We need to zoom out from that single cucumber to see the entire journey. From the microscopic bacteria in the soil where the food begins.
All the way to the trash bin in my kitchen where that plastic ends up.
All the way there. The whole journey.
Okay, so let me unpack this a little. We're usually told to focus on one thing at a time, right? Buy organic or ban plastic straws or eat less meat. We tend to put these issues in their own little boxes.
We compartmentalize them. But today, we're trying to connect two ends of a very, very long chain.
Precisely. And we've got a fascinating stack of research for this deep dive that, seems totally disconnected at first glance.
It really does.
On one side, we have this massive 2025 review called From Soil to Health, which goes deep, really deep, into regenerative agriculture, soil microbiology, and human nutrition. It's all the heavy biological science of how we grow things.
And then on the other side, we have this report commissioned by the Oregon Department of Environmental Quality.
Yeah, that one's called Packaging and Wasted Food.
And this one is completely different. It's all about life cycle assessments, carbon footprints of trash, and yes, the defense of my enemy, the shrink-wrapped cucumber.
So the goal today is to mesh these two worlds together. We've got a projected global population peaking at over 10 billion people.
Which is just a mind-boggling number.
It is. So the core question really is, how do we feed 10 billion people without completely destroying the biosphere? And the answer, as you might guess, is surprisingly complex. It involves everything from something called fungal dominance in the soil to intelligent packaging for your avocados.
So we're really asking if we can fix this whole massive food system by looking at the very beginning, the dirt, and the very end, the waste.
And we have to start with the dirt. Or, as the scientists would really prefer, we call it the soil. Please never call it dirt in front of an agronomist.
Duly noted. I will not make that mistake. Okay, let's dig in. Section 1 here deals with what our sources are calling the soil crisis. Now, I think most people know that factory farming or, industrial agriculture has some issues.
Sure.
We've all seen the documentaries. But the stats in this regenerative agriculture review were honestly staggering.
They are pretty sobering. You really have to visualize the scale of it. Industrial agriculture currently occupies about 40% of the Earth's land mass.
40%.
That's roughly 50.4 billion acres. And the source states it quite clearly. Agricultural land management is the human activity most detrimental to the environment.
That is a huge statement. Most detrimental. You're saying more than transportation, more than the entire energy sector.
In terms of its direct impact on ecosystem functions and just the sheer amount of land it physically occupies, yes. We have essentially terraformed the planet just to grow food.
Wow.
And the damages cited are very specific. We have moved toward massive monocropping. This statistic it blew my mind. Just 9 plants account for 66% of global crop production.
Wait, hold on, pause on that. 9, that's it. We have thousands, tens of thousands of edible plant species in the world, and we're relying on 9 of them for 2/3 of everything we grow.
It's unbelievable, isn't it? Maize, rice, wheat, soybeans, those are the titans, we've completely homogenized the landscape.
We've turned these complex ecosystems into factories for these few specific crops.
That's the perfect word for it, factories. And to keep those monoculture factories running, we have to constantly fight against nature. We use tillage plowing of the earth, and then we pour on massive amounts of synthetic fertilizers and pesticides.
And the source details how this just wrecks the soil, right? It disrupts carbon storage, it kills biodiversity.
Exactly. It's not just that we are growing food, it's that we are mining the soil to do it.
Mining the soil. That is such a vivid image. It really implies we're taking something out that we aren't putting back in.
And we aren't. We're depleting it.
The source also brought up the insect apocalypse as a direct consequence of this. That sounds like a sci-fi movie title.
It really does.
But it refers to the very real collapse of insect populations, mainly due to pesticide use and just total habitat loss.
It's not sci-fi, unfortunately. It's happening right now. And then, of course, there's topsoil loss. They brought up the Dust Bowl as a historical reference point.
Which feels like ancient history to us, right? You see those black and white photos of dust storms in the 1930s. But the report basically argues we're setting ourselves up for a sequel.
We are, because the Dust Bowl happened for the exact same reasons. We treated the soil like it was dead matter, like it was just something to be manipulated, rather than a living system.
We stripped the cover, we plowed too deep.
And the wind took the rest. And the irony, as you pointed out earlier, is that we are producing massive amounts of calories. We are very, very good at yield. We have more corn than we know what to do with, but are we producing health?
And that's the perfect pivot to regenerative agriculture. It is such a buzzword right now. I feel like I see it on everything from cereal boxes to T-shirts. But what does it actually mean? Because the source highlights a bit of a problem with that definition.
It is the Wild West of labeling right now. That's a great way to put it. Unlike organic, which has the USDA seal and the National Organic Program with very strict legal definitions.
And lawyers involved if you fake it.
And lawyers? Yes. Regenerative doesn't have a single universally accepted definition or a centralized government certification. Not yet, anyway.
So if a massive food conglomerate says their cornflakes are regenerative, they could mean pretty much anything. Like they planted a tree in the parking lot once.
Potentially.
Yeah.
It is highly, highly susceptible to greenwashing right now. However, the source does provide a good working definition that's gaining consensus in the scientific community.
Okay, what is it?
It's defined not just by what you don't do, but by the positive impact you have. It's a set of practices aimed at restoring soil health, capturing soil carbon, and actually reversing biodiversity loss. It's all about the outcomes. Is the land healthier after you farm it?
So it's about making things better, not just less bad.
Precisely. And the source was very careful to point out that this isn't exactly new technology.
Wow.
This isn't something that was invented in a lab in Silicon Valley last year. No, and that it's such a crucial point. The term regenerative agriculture was popularized back in the 1980s by the Rodale Institute. But the actual practices, keeping the soil covered, not disturbing the ground, rotating crops, these have roots in indigenous practices from millennia ago.
The source explicitly mentions things like the milpa systems in Mesoamerica.
Or the Zai pits in the Sahel.
Can you explain Zai pits? I've heard the term, but I'm not sure I actually know how they work.
Oh, they're brilliant in their simplicity. It's a technique used in very arid regions to combat desertification. So you dig these small pits into the hard-crusted soil and you fill them with organic matter, manure, compost, whatever you have.
Okay.
When it finally rains, those pits capture and hold the water and all those nutrients, concentrating them right where the plant roots need them most. It literally turns barren land back into productive land without needing massive irrigation systems.
That's incredible.
These were regenerative systems long before we gave them a fancy marketing name.
So we're essentially rediscovering this ancient wisdom that we plowed over in the name of efficiency. So what are the specific practices today that would differentiate this from just standard farming?
There are a few key pillars. One of the biggest is cover cropping.
Which means never leaving the soil bare.
Exactly. Never leaving it exposed to the sun and the wind. Another is biomass retention, which is a fancy way of saying you leave the plant matter on the field after you harvest instead of clearing it all away.
You let the stalks and leaves rot back into the ground.
You feed the soil. And, crucially, reduced tillage, or no-till, ideally. You have to stop breaking up the soil structure with heavy machinery.
Okay, so if this is the answer to the soil crisis, if this fixes the carbon issue and the water issue and the biodiversity issue, everyone must be rushing to do it, right?
You would hope so,
Yeah.
but the scale of the challenge here it's daunting. The
Hmm.
source uses organic farming as a proxy because, like we said, the stats on regenerative are still hard to pin down.
And what are the organic numbers?
Organic farming currently accounts for less than 2% of global farmland.
Less than 2%. That's it.
Less than 2%. And since true regenerative farming is often considered a step beyond organic, the actual acreage is likely even smaller than that.
Wow.
So when we talk about this as a revolution, we have to be realistic. We're talking about a tiny fraction of the food system trying to overturn a massive entrenched industrial complex.
That is, yeah, that's pretty discouraging. It feels like David versus Goliath, but Goliath has government subsidies.
That's a good way to put it.
But let's look at why it's worth the fight. Section 2 of our deep dive is this soil-to-gut connection. This was the part of the research that gave me the biggest aha moment. It connects the farm directly to my own body.
This is where the biology gets really, really cool. We need to stop thinking of soil as dirt, as just this inert physical stand to hold a plant up, and start thinking of it as a biological engine,
A living system.
a massively complex living system. A single teaspoon of healthy soil can contain billions of microorganisms.
Billion.
And the source breaks down the key players, bacteria and fungi. In a healthy ecosystem like a forest or a healthy prairie, you need a balance of both. But industrial agriculture, specifically the constant tillage and the chemicals, it shifts that balance dramatically.
How so? What does the plow actually do to the biology down there?
Well, think about fungi, specifically something called mycorrhizal fungi. They grow these incredibly long, delicate threads called hyphae.
Okay.
They form this massive network, a literal web underground. Sometimes people call it the wood wide web.
I've heard that term.
Right. So when you drive a giant plow through that, you are physically shredding that network to pieces. You're destroying the infrastructure.
Yeah.
So industrial soils tend to become bacterial dominant because bacteria can survive that kind of constant disturbance better.
Okay, and why does that matter? Why should I, as a consumer, care if my soil is bacterial instead of fungal?
Because the fungi are the heavy lifters when it comes to carbon sequestration. The source explains that fungi produce these amazing compounds, glomalin's a big one, that act like a superglue. They glue soil particles together into aggregates.
And that's what holds the carbon?
That's what locks the carbon into the ground and keeps it there. So less fungi means less carbon storage. It also means the plants have a much harder time accessing nutrients from the soil. The fungi act like a nutrient delivery service.
Which leads directly to the nutrient density decline. This is the part that's really scary. The source dropped a fact that I think a lot of listeners might have heard rumors of, but seeing it in a peer-reviewed paper is different. Crops today are physically less nutritious than they were 60 years ago.
Yes, and this is a well-documented phenomenon known as the dilution effect. It's a combination of things. For decades, we have been breeding crops almost exclusively for yield, for fast growth, big size, long shelf life.
We want the biggest tomato possible.
We want the biggest tomato that can survive a cross-country truck ride. But the soil it's growing in is degraded. So the plant grows big and starchy, but it just can't pull up the same density of minerals, vitamins, and phytochemicals because the biology in the soil isn't there to help it.
So we are literally eating hollow food. It looks like an apple, but it's chemically empty compared to what our grandparents ate.
To a certain extent, yes. The source cites a number of studies that compare crops from regenerative farms versus conventional ones. They found really significant differences in phytochemicals, things like antioxidants, polyphenols, in leafy greens and grains when the soil's organic matter is higher.
So you're literally getting more health per bite when the soil is alive.
That's the takeaway. More nutrition per calorie.
And this connects directly to us, to our own bodies. The paper calls it the One Health concept.
This is the beautiful symmetry of nature. It's so elegant. The soil microbiome looks a lot like the human gut microbiome. The source draws a direct, unbroken line. Biodiversity in the soil leads to biodiversity in the diet, which in turn leads to biodiversity in the human gut.
And we know that gut biodiversity is the holy grail of health right now. Every single health podcast is talking about the microbiome.
It is. It's central to everything from our immune system to our mental health. The source uses the incredible example of the Yanomami people in the Amazon.
Right.
Their gut microbiome has the highest genetic diversity ever recorded in humans. They eat a massive variety of plants and animals. They have essentially no exposure to antibiotics. and they live in an incredibly biodiverse environment.
They're essentially rewilding their guts every single day.
That's the perfect way to describe it. Now, contrast that with the typical urban dweller in New York or London or here.
Right, we've lost so much of that internal wildlife.
We really have. The source notes that rural populations, even today, tend to have more bacteria like Prevotella, which are fantastic at degrading complex carbohydrates from plants.
And urban populations.
Urban populations who eat what the source calls ultra-processed foods, or UPFs, have drastically reduced diversity. We are essentially monocropping our own guts.
That is a terrifying image, monocropping our guts.
It fits, though, doesn't it?
Yeah.
If you feed your gut ecosystem nothing but refined sugar, refined wheat, and industrial seed oils, which is what most UPFs are, you are selecting for a very specific and very limited set of bacteria to thrive.
You're creating an internal monoculture.
And the cost of this cheap industrial ultra-processed food isn't cheap at all. The source estimates the hidden costs of the global food system exceed $10 trillion.
10 trillion. With a T, that is just an unfathomable amount of money.
Most of it is due to healthcare costs from non-communicable diseases, or NCDs, things like diabetes, obesity, heart disease.
The diseases of modern civilization.
Exactly. These are diseases that are strongly linked to gut dysbiosis and chronic inflammation, which are driven by foods specifically designed by corporations to be hypopalatable and, frankly, addictive.
So, okay, let me see if I can trace the line here. We degrade the soil with industrial practices like tillage. Then we grow massive amounts of nutritionally empty, starchy commodity crops. We then turn those crops into ultra-processed food. That food degrades our gut health. We get sick, and we end up spending trillions of dollars trying to fix the sickness.
That is the cycle. You've nailed it. And that is why regenerative agriculture isn't just about saving the planet in some abstract, far-off sense. It's about saving our own internal ecosystem. It's about public health.
Okay, that is the heavy foundational stuff. It's a lot to take in. We need to fix the soil to make the food healthy. But now I want to pivot to the other end of that long chain, because even if we grow the most nutrient-dense, regenerative, fungal-rich carrot in the history of the world, it doesn't matter one bit if it just rots in my fridge and I throw it away.
Correct. And this brings us right to Section 3, the packaging paradox, and back to your cucumber.
The source from the Oregon Department of Environmental Quality hits us with a stat right away that it hurts to read. 30 to 40% of all edible food in the U.S. is wasted.
Just let that sink in for a second. Almost 1 out of every 3 calories we produce, and think of all the land, the water, the labor, the diesel fuel that went into that, is never eaten.
It goes straight to the landfill.
Straight to the landfill. And the environmental impact of that waste is astronomical. The source says that producing all that wasted food generates greenhouse gas emissions equivalent to 33 million passenger vehicles driven for a whole year.
So when I throw away that half-eaten bag of salad greens, which I have to admit I do way more often than I'd like, I'm not just wasting the lettuce.
Not at all.
I'm wasting the tractor fuel, the fertilizer production, the transport emissions, the refrigeration at the store, everything that went into making it.
Exactly. Food production is incredibly resource intensive. The embedded energy in a single cucumber is surprisingly high. And this is where we have to come back and revisit your nemesis, the shrink-wrapped cucumber.
I am ready. Defend the plastic. I am listening with an open mind.
Okay, so this is all based on something called a life cycle assessment, or LCA. The Oregon report breaks it down really clearly. That plastic wrap weighs about 1.5 grams.
Okay, tiny.
It is a tiny, tiny amount of material. But that tiny amount of plastic extends the shelf life of that cucumber from about 3 days to over 2 weeks.
2 weeks. That is a huge difference. I had no idea it was that much.
It's a massive difference. Naked cucumbers lose moisture incredibly fast. They get soft, they get mushy, they rot. So if that plastic wrap prevents the cucumber from being thrown away, the environmental math usually, not always, but usually works out in favor of the plastic.
Because the carbon footprint of growing and shipping the entire cucumber is so much higher than the carbon footprint of that 1.5 grams of plastic.
That's it. You're trading a tiny bit of packaging for a huge reduction in food waste. The plastic is the lesser of two evils.
Okay.
Now, the report does note exceptions. If a grocery store has incredibly efficient turnover and extremely low waste rates already, maybe under 3.7%, then the plastic might become a net negative. But for the average supply chain,
It's a win.
it's a net environmental win. Saving the food is a priority because the food embodies so much energy.
The report gives us a really useful rule of thumb for this, which they call the meat versus lettuce rule. Can you explain that? Because I found this really helpful for navigating the grocery store with a bit less anxiety.
It is a great mental shortcut for listeners.
Yeah.
It's really simple. You just have to look at the carbon footprint of producing the food versus the carbon footprint of producing its packaging.
Okay.
So let's take beef. The emissions from producing beef, raising the cow, growing its feed, the methane, they're huge.
Very high impact.
Extremely high impact. By comparison, the packaging emissions, the styrofoam tray, the plastic wrap, they're a tiny fraction of the total.
A drop in the bucket.
Exactly. So the verdict is, always package meat well. If a vacuum seal prevents even 1% of that steak from spoiling, it easily justifies the environmental cost of a lot of plastic. Because wasting the steak is an environmental disaster.
Okay, so high-impact foods like meat, cheese, dairy, the packaging is almost always worth it because the cost of wasting the food is so high. What about the lettuce?
Vegetables have a much lower production footprint, so
Yeah.
the ratio is closer. The packaging matters more there. You don't want to overpackage a carrot the same way you might package a filet mignon. But even then, as we saw with the cucumber, the packaging often still pays off.
There is one specific case study in the Oregon report that I found absolutely hilarious, but also very, very telling about the role of human behavior in all this.
Okay.
It was the battle between the tube of ground beef and the tray.
Ah, yes, the chub versus the tray.
Yeah.
A classic LCA showdown.
The chub, that's what they really call it.
That is the official industry term, yes. You know, that tube of ground beef that looks kind of like a sausage?
Right.
From a strictly material standpoint, if you're just looking at the amount of plastic used, the chub is the clear winner. It uses much less plastic than a rigid tray. It's lighter, it ships more efficiently, it's better on paper.
So logically, if we all want to save the planet, we should be buying the chubs.
Ideally, yes. But the life cycle assessment revealed a hidden and very important variable: human behavior.
What happened?
It turns out people can't get all the beef out of the tube.
Oh, I have struggled with this. You squeeze it, you try to roll it up like a tube of toothpaste, but there's always that little bit that gets trapped in the metal crimp at the end.
Well, the study found that on average, about 1% of the beef sticks to the inside of the tube and gets thrown away with the packaging. And here's the kicker.
Uh-oh.
That 1% wasted beef creates more greenhouse gases than all the savings you got from using the thinner plastic in the first place.
No way! That is wild. The waste of the food completely outweighs the benefit of the supposedly eco-friendly packaging.
And it gets even worse. The report also noted that people are far more likely to rinse and recycle a clean plastic tray than they are to deal with a slimy, meat-covered plastic tube.
Oh, absolutely not. That tube is going straight in the trash.
So in the real world, the tray might actually be the better environmental option simply because humans are, well, we're humans. We aren't perfectly efficient robots.
This really complicates the simple narrative, doesn't it? It's not just plastic is bad. It's how do we interact with this packaging to minimize the much bigger problem of food waste?
Precisely. The report challenges us to look at the net environmental outcome, not just the size of the pile of trash in our bin. If the packaging saves the food, it's doing a very, very important job.
Okay, so let's zoom out again. We've established that we need to fix the soil to make the food we grow healthy, and we need to be smart about packaging to keep from wasting that food. But this leads to the really big questions in Section 4. Why isn't this happening already? If regenerative agriculture is so great, why is it stuck at less than 2% of the land?
This is the core of the frustration, isn't it? The science is there, the models are there, but the system is stuck. The source calls it the agricultural treadmill.
The treadmill? That sounds exhausting.
It is for farmers. I mean, think about it. Most farmers operate on incredibly thin margins. They often carry huge amounts of debt for their land and equipment. They're completely locked into a system where they have to buy expensive inputs, patented seeds, synthetic fertilizers, pesticides, to get a predictable yield that they then have to sell at volatile commodity prices.
So they're just running faster and faster to stay in the same place.
That's it. So they can't risk changing their methods. Transitioning to a regenerative system takes time. When you stop tilling and spraying, your soil doesn't just magically recover overnight. It's a biological process.
You might have a yield dip for a few years.
You almost certainly will have a yield dip for a few years before the soil biology bounces back and it becomes more productive. A farmer who is living year to year on bank loans literally cannot afford to take that risk without some kind of support or safety net.
And the government policy isn't providing that safety net.
For the most part, no. The source highlights some pretty significant policy gaps. Government subsidies heavily favor those monocultures we talked about, corn and soy.
Right.
And crop insurance, which is the main safety net, often requires farmers to use conventional practices, which means if you try something new, like intercropping different plants or using cover crops, and it fails, you might not even be covered by your insurance.
Wow, so it actively discourages innovation?
In many cases, yes. And there's a huge size bias, right? The source notes that most of these policies and subsidies are designed for massive farms operations that are over 1,000 acres. Small and medium-sized farms, which are often the ones most willing and able to innovate and farm regeneratively, are largely left out of these incentive structures.
So how do we break the treadmill? The expert source discusses this idea of choice architecture. What is that?
This is a really powerful concept from behavioral economics. It basically means designing the system so that the good choice is also the easy choice. We can't just rely on individual farmers being heroes or individual consumers doing hours of research for every single purchase. We have to change the system itself.
Okay, give me an example of what that looks like in practice.
A huge one is institutional procurement. This is a massive, underutilized lever for change. The source points to New York's Farmed Institution Initiative as a great model. They set a 30% procurement incentive.
What does that mean, a 30% incentive?
It means that institutions that buy massive amounts of food, think schools, hospitals, prisons, state universities, are financially incentivized to buy 30% of their food from local New York farms. The state basically helps cover the cost.
Well, that changes the math completely.
Yeah. It changes everything. If you're a farmer and you have the state of New York saying, hey, we will buy all of your regenerative carrots for all of our public school lunches at a stable price, suddenly you have a massive stable market. You aren't just gambling on the global commodity price anymore. You can actually afford to transition.
That's so powerful. It creates a guaranteed demand that allows for innovation.
Another huge area for this is the concept of food as medicine. The source argues for fully integrating food into our healthcare system. We spend $4.1 trillion on healthcare in the U.S. every year, and so much of that is on treating those diet-related, non-communicable diseases we mentioned.
So instead of just prescribing pills for, say, type 2 diabetes or hypertension, a doctor could literally write a prescription for vegetables.
For nutrient-dense, regeneratively grown vegetables, and insurance pays for it. This isn't just some hippie dream. There are pilot programs for this happening right now. If we redirected even a tiny fraction of that $4.1 trillion healthcare spend toward regenerative food systems, it would transform the agricultural landscape overnight.
It connects the soil to gut loop financially. It makes the healthy choice the profitable choice.
Exactly.
That brings it all back to the listener. We've talked about billions of acres and trillions of dollars, but what can the person listening to this deep dive actually do besides, staring anxiously at the plastic wrap on their cucumber?
The first thing, honestly, is to let go of the plastic guilt, if that plastic is saving food. The Oregon report is crystal clear. Reducing your own food waste is the #1 most impactful environmental action you can take in your own kitchen.
So if the wrap helps you eat the cucumber, use the wrap.
If it helps you eat the cucumber, use the wrap. Don't let the perfect be the enemy of the good.
Okay, that's a relief. What else?
Beyond that, if you can, look for what the source calls committed organic markets. They draw a distinction between pragmatic organic buyers, big chains that just want a product to sell at a markup, and committed organic markets that actually support the philosophy of soil health.
And community-supported agriculture, or CSAs, would fall into that category.
CSAs are perfect for this. They break the industrial mold entirely. You are creating a direct relationship with a farmer.
And what about labels? Since we said regenerative is the Wild West, what should we actually look for on a package?
This is tough, but it's getting better. The source suggests looking for specific third-party certifications that are trying to bring some real rigor to the term. Regenerative Organic Certified, or ROC, is probably the gold standard right now because it requires the USDA Organic Baseline plus strict standards for soil health and animal welfare.
Okay, ROC. Anything else?
Another good one is Land to Market, which is an outcomes-based certification. They actually measure the ecological health of the land to verify that it's regenerating.
So the takeaway is to demand clarity. Don't just buy the regenerative cereal because the box is painted green and has a picture of a farm on it.
Exactly. Be a curious eater. Ask questions about where your food comes from and how it was grown. Your questions create market pressure.
We have covered so much ground today. I mean, from the microscopic fungi networks under our feet to the global supply chain of plastic film.
It really is a story about connection, isn't it? Everything touches everything else.
So if you had to summarize the mission of this deep dive, or the core idea of how we fix the food system, how would you boil it all down?
I would say it's about moving from a linear model to a circular one. The industrial model is completely linear. You extract nutrients from the soil, you turn them into food, you wrap them in disposable trash, you eat some of it, and you dump all the waste into a landfill. It's a straight line to depletion and pollution.
And the solution is to bend that line into a circle.
It's to see it as a living system. We heal the soil so it can cycle nutrients naturally. We eat the food grown in that soil to heal our own gut microbiome. We use packaging intelligently as a tool to ensure that that precious nutrition actually reaches us instead of rotting. And we design policies that treat food not just as a commodity, but as the literal foundation of public health.
It's a complete shift in perspective. Instead of seeing a farm as a factory, we need to see it as an ecosystem.
And we need to see ourselves as part of that ecosystem, not separate from it.
I want to leave the listener with a final thought, something to kind of mull over while they are unpacking their groceries this week. We often think of technology as, silicon chips and AI and satellites.
Right, the shiny new thing.
The shiny new thing. But the most advanced piece of technology we've discussed today is 40 years old, or really thousands of years old. It's the definition of regenerative agriculture. It's the innate ability of soil to heal itself, to sequester carbon, and to produce health.
And the other piece of high tech? Well, it might be a 1.5-gram piece of plastic that keeps a cucumber fresh for 2 extra weeks.
It's a total paradox.
It really is.
So here's a question for you to think about. How would you eat differently if you thought of your dinner plate not as a consumer product you bought, but as a direct extension of a soil ecosystem? If you visualize that fork full of food as the final step in a process that started with a fungal network deep underground.
It changes everything. It makes every single bite an active participation in that system, for better or for worse.
Thanks for diving deep with us today.
Always a pleasure.
We'll see you next time on The Deep Dive. Stay curious, and maybe, just maybe, give that shrink-wrapped cucumber a break.